Hi guys, this video is going to take the example that I used to introduce hypothesis testing in the weekly notes, and we're going to complete a full hypothesis test on this using the p-value method. You're going to see that there's two methods, using the p-value method or using the critical value method. Okay, so I'm going to list out the steps for using the p-value method, and then we'll also do it alongside with this one. Okay, so the first step for no matter what method we're doing, the first step is going to always be to state your null hypothesis and your alternative hypothesis. So what I like to do is I first like to take the claim and figure out what the claim is in symbols. Okay, so the claim here is that a company's claiming that all their lawnmowers last on average of at least 8.7 years. So they're claiming that the population average, that's why I'm using mu, is greater than or equal to 8.7. Okay, so the reason I do that is because then I can decide where this claim is going to go. Okay, so since it has an equal to, it automatically goes in H sub 0. So it actually has nothing to do with, the claim does not always go in H sub 0. That's the mistake sometimes people think. This one claim is going into H sub 0 because it has the equal to in it. Otherwise, if it didn't have an equal to, it would go in H sub A. Okay, so the alternative hypothesis would be the complement of this, okay, which is mu less than 8.7. So the idea is, for us to be able to test this, we have to take a sample. We can't test all the lawnmowers, so we take a sample of 50, and we figure out what is the average lifespan for those 50. And it came out to be 8.5, so it's definitely didn't come out to be greater than 8.7, but that doesn't mean that we can reject H sub 0 or reject the claim. It might not be far enough away from 8.7 to really say that we have enough evidence that it's not true. So I'm just going to label this one being my claim so that I know in the end, if I make a decision to reject H sub 0, I know if that means I'm going to support my claim or not. So my second step is to identify a bunch of things. Okay, so I'm going to identify, sometimes I have to find these values, but in this problem they're given to me. Identify what happened with the sample, what did the sample's average come out to be, okay? What was the standard deviation of the sample? How big was the sample, N, and what level alpha, okay? And then we're going to determine also what kind of test this is. Determine if this is, I'm going to abbreviate here, if it's a right-tailed, a left-tailed, or a two-tailed. Okay, those are the things we're going to do next. All right, so do this. So there's our, I just rewrote our null and alternative hypothesis. So in this case, let's see, the actual sample came out to have an average of 8.5. The sample standard deviation was 0.9. N was 50, which is large enough to use the normal distribution as long as it's over 30. And sigma, alpha, I had said to use 0.01. Okay, so and what kind of test is this? Well, if you look here, okay, that's what tells you what kind of test it is. Because this says we're going to reject H sub 0 for if we get small values, things that are too much below 8.7, because then H sub 0 is probably not true. We don't know if 8.5 is, small enough to reject, but that's how I know that this is a left-tailed test, and this really helps when you're just making your decision and finding your p-value. Okay, so this is a left-tailed test. Okay, so our next step, our step 3 we're on, is to find your z-score and p-value. Okay, the p-value, the reason why I like to have this graph drawn out is because we can see the p-value is just a shaded area. So when I find my z-score, I'm going to find the area to the left of it, and that's going to be my p-value. P-value is just a probability. Okay, so let's find our z-score. So our z-score is, okay, it's going to be our actual mean, meaning that's what came from the sample, that's what came from the research, Then minus our hypothesized mean, which is 8.7. Our z-score is going to be negative because our actual sample statistic came out lower than the population, the claim about it, over our standard deviation divided by square root of n. Okay, so if you do this, you just have to be very careful how you're putting into the calculator. You should get about negative 1.57. Okay, so that means that this value right here is negative 1.57. Okay, so I need to find the area to the left of that. So I do that one of two ways. I use the table, which gives me the area to the left, so I wouldn't even have to do the complement. Or I use the calculator and go normal CDF from negative 10 to negative 1.57. That will get me the area to the left of that value. So I'm doing that right now. And I get, let's see. I'm doing normal CDF from negative 10 to negative 1.57. And I get about 0.0582. Okay? So that means I have about a 5.82% chance of getting a value like 8.5, and that's assuming that the null hypothesis is true. Okay, so our next step, what we use this p-value is to make our decision. Okay, so our next step is going to be to compare the p-value, this is our p-value right here, to our alpha, which is right here. Okay, so next step, Step 4 would be make a decision, I'll say compare P and alpha to make our decision. Okay, so our decision is either going to be to reject h sub 0 or fail to reject h sub 0. So here's our decision maker. Okay, if P is less than alpha, then we reject h sub 0. If P comes out really, really small, it's really saying that it's very unlikely to get a probability the way what we got assuming h sub 0 is true, so which means h sub 0 is probably not true if P gets very, very small. If P is greater than or equal to alpha, then we fail to reject. Notice my decision is about h sub 0. It's not about the claim. Okay, whether we support the claim or not will come after. So in our problem, let me write out what we have. Our p-value was 0.0582, and our alpha was 0.01. Okay, you can see different levels of alpha could give me a different decision when I compare it against p. So in this case, our p-value is greater than our alpha. So our decision is going to be to fail to reject h sub 0, which really means we do not reject. That fail to reject means we are not rejecting h sub 0, which means we're kind of accepting it, although we don't usually use those words. We usually say we have not found enough evidence to say otherwise. Okay, so one more thing here let me write out what we had in the very beginning was h sub 0 and h sub a. This one was greater than or equal to 8.7, so this was our claim. And then less than 8.7 was our alternative. So our decision was to fail to reject based on our p-value. Okay, so what I usually do here is I kind of circle the one I'm saying is kind of quote-unquote true. Okay, if I'm failing to reject, if I'm not rejecting h sub 0, it means I'm going with h sub 0. I have not found any other enough evidence to say otherwise. So I'm going to go with h sub 0 and say that's the more true of the two. So because I'm going with h sub 0, do you see when I circled it, I circled my claim at the same time. So that means that I am able to support the company's claim. I could not find enough evidence to not support them. So these two things do not always go hand in hand. It depends on where your claim is. If my claim happened to be an H sub A for this one, and I did not reject H sub 0, it would mean something different. It would mean I couldn't support my claim. So it really depends on where your claim is. But our first decision is always to decide what are we doing about H sub 0 using that p-value. And then we go back and say, okay, does that mean I can support the claim or not? So the two methods that we use here, the next one you're going to see in the other video, they arrive at the same exact conclusion, the same exact decision. It's just this method compares probabilities, which P and alpha are both probabilities. And you'll see in the next method we compare z-scores instead to make our decision. So hopefully it helps to have the steps written out for this problem. And then do some practice with the p-value method before you move on to the other one, because you don't want to get the two methods confused. Okay, I hope that helps.